Okay, so my talk has a very long title, but in essence, it's our business case for Puppet Enterprise. And so just a little bit about UT. UT is, our servers are still more in the line of cattle than they are, more in the line of pets than they are cattle. Because we have about 550 nodes. So we don't have a ton in enterprise, but we have a lot of different contributors to Puppet. And so our struggle has been less in terms of vertical scaling than horizontal. We want to have a lot of contributors, and we don't want them to necessarily have to know the DSL or have to dig into it. And so the question is, who is everybody exactly? And basically, when we say everybody, we mean everybody who has a vested interest in controlling configurations on a server. And so as you can see, that's development, to push things to their code, certainly operations, and even management, because they may want to see code or see what's being done, or auditors, or anything like that. And we've actually found that the Puppet Enterprise console is a really fantastic kind of point of entry for all of these folks. The trick is that there's kind of a continuum of expertise, right? Everybody starts on the left-hand side, and that looked better when I set it up. So everybody starts out as a novice, right? But even for somebody who's brand new to Puppet, you can log into the console. You can see classes and nodes and variables. And so it's fairly straightforward. And then, so we wanted to be able to accept and have a service that was available for people who are novices all the way to experts, right? And the experts being people who can write Puppet code, write custom facts or functions. And then everybody in between, which is, in this case, is Hiera. Hiera is kind of, a little bit of both. And so we came up with kind of a Puppet Canon, kind of a set of baseline principles that we wanted our Puppet installation to follow. And that canon was that it should be inclusive, and not just for the kind of the neophytes, but also for the people who are very experienced with Puppet. And you'll see how we did that using the tool sets. We also wanted it to be secure by default. We wanted that no matter where you plugged into Puppet, that you got our basic security baselines. And finally, we wanted it to be federated. And we basically, and I'll show you, we did that by pulling source, by code and data from a bunch of different source repositories. But we wanted people to be able to make changes at their own particular level. The way that we typically put it is that you can break your own stuff. We just don't want you breaking your neighbor's stuff. And so the way that we did this was by implementing this wonderful PowerPoint graph that we call the UT Puppet Toolset. And as you can see, the middle is Puppet Enterprise, right? That's the basic software package that we all know and love. But then we bolted on our own particular pieces. The top, and I would say the most important, was the UT Puppet community. Right? That was the kind of the people power, all the things related to the people who are actually going to use the tool. The second was nested configurations, which I'll show you what we did in the enterprise console. And finally was the code and data federation, which we did via pulling Puppet code and Hiera data from different source repositories. So first, and this picture may look familiar, at least a little bit. There's no creepy eye at the top. This actually wasn't intentional. So first, and really I would say the most important, is the building a Puppet community at UT. Is trying to, and I know a lot of people have talked about this, but it really is very important because you can have the best tool in the world, and if nobody uses it, it's not really going to be of a lot of use. And so when we talk about UT Puppet culture, we're primarily talking about all of the things that make Puppet go at UT. First and foremost, that's your coding standards, right? And for us, we have a lot of specific standards that we all follow, and they're documented. We use top-level variables pretty extensively. We tend to we actually have a mode variable that says if a particular class is enabled, disabled, or set to purge. Just things like that, just basic coding standards that are the same across all of our stuff, or that should be. We also have skeleton modules that we publish that people can get into writing code, and it just sets it up for them. The second is documentation standards. And this is kind of a broad concept. It's basically not only what should be documented, but where you can find that documentation, just everything kind of relating to what modules do, how they do it, which is really important, you know, because if you don't know what a class does, it's hard to use it. And finally, and arguably the most important, is I named Power to the People. And this is basically all of the kind of the soft things around UT Puppet culture. It's the Puppet user groups. It's the meetings in the hall. It's kind of being available to help build this community at UT. It's stuff like this, actually, on a UT scale. Next. So this is, all right, that looks all right. This is a diagram of our UT Puppet infrastructure, and we'll come back to this several times. And this, basically, we have a novice track and an expert track, and the mid-level track kind of just add Hiera without the code. And so the point of this was to show that a novice to Puppet can come in and control almost everything they need simply via the Puppet Enterprise Console. And so that involves, as you can see, it's classes, console groups, which we're using to kind of replicate the role and profile pattern, which I'll show you, and then set console variables. And then from just setting those things, basically, you get a configured server. So that's nice. But but we also have a kind of an expert path that on top of that, and they still use the console, they can also use Hiera for more complex data structures, and they can also write their own code, which is cool. All right, so that was no, didn't fix the slide. That was the community part. Now the bottom left of the triangle is about nested configurations. And this is kind of the heart of how we do things at Puppet. And I would actually like to put in a quick plug for the new Puppet Enterprise 3.4, because you can actually do the same thing even easier using their stuff. So I definitely highly recommend the RBAC demo, which is awesome. So nested configurations, basically, what we're doing is we're replicating the role and profile pattern in the enterprise console, kind of. That it didn't start out intending to be that way, but it pretty much worked out that's what we were doing. And just as a reminder, roles and profiles are set up to where you can have a large base, right, that has a lot of standardized stuff, right? Like I say, secure by default. You can be SSH configurations, NTP configurations, just your basic stuff that every node should get. And then on top of that, you can layer in, let's say you have Apache configurations. That's a profile, right? Apache will contain everything that the base gets plus Apache. And then on top of that pyramid, let's say you're a wiki server. Well, you're also an Apache server, and you're also a base server. So it gives you different kind of layers to build up, to build the Puppet cake. So as a metaphor for roles and profiles, and this is my first funny slide, you can use a minifigure metaphor, is that we provide at the base layer kind of a default torso, and then you can configure that torso, but then you can also add heads, arms, capes, cows, whatever. You can add your own configuration to that. And so what we do is that in the enterprise console, we nest everything, basically. And so everything goes back to an enterprise group, a node group. And so we nest the groups using role, profile, and base. And because of that, we also nest variables, and we even kind of nest Hiera, which is pretty cool. And I'll show you that later. So back to the roadmap. So this part will be about the nesting in the console. So nested console groups are Russian nesting dolls, Matryoshka dolls. And that actually is a really good analogy for how we do this. And I struggled for an analogy to show you guys. And it's a good one. So this is basically what we do. So you take we have all these, and all these relate, except for the bottom one, to a console group in the enterprise console. And so at the outside layer are all of the base configurations you get, like I referred to. SSH is a good example. Let's say you want to configure SSH on every node. So that goes in the base. But then you can have at your Apache level, you can have a what I call a profile underscore Apache node group. And that naming scheme is intentional since it shows you what kind of thing that is, like what layer it is. And that'll just have your Apache configs. And then within that, like the little doll, is another one called a role wiki. And those are only your wiki configs in the console. And so if at the very center of that, I don't know, that jawbreaker, I guess it kind of looks like a jawbreaker too, is the wiki 01 node. And the wiki 01 node is directly a member of the role wiki, right? But which is a member of Apache, which is a member of base. And so it gets a combination of all of those since inheritance works down through the nesting, which is cool. So from the node's point of view, that node says, well, I'm wiki 01, and I'm directly a member of role wiki, which is a member of profile Apache, which is a member of base. And so I'm indirectly a member of all of these things. So here's another view of that. And you can see, if you guys can make that out, role wiki's on the right there. And that's cool, right? So you have wiki 01, wiki 02. And so at this point, hopefully, all of the configurations for that server are within those 3 different layers, right? So you have your base, you have your profile layer, and then you have your role layer. And so that should be all the kind of business logic relating to that server, not including the IP address and anything that's node specific. So at the node level, they're cattle, right, essentially. Although we still have some node level stuff. But what's nice here is that having set this up, you can come along and say, well, let's see, I have blog servers too. So you add a blog role, right? And then that plugs into the profile Apache profile, and then you got blogs, right? And it's as easy as that. And the only thing you have to configure in there is what's unique about blogs that doesn't have anything to do with Apache and that doesn't have to do with base configs. So I've got an example of that. Oh, and I say here at the bottom, what's really nice about this is that you don't have any repetition, right? Or you don't have to have a repetition because you can actually pull that out, which is nice. And just a quick thing about the naming scheme is that the names are, I guess you notice that they're prefixed with kind of the layer that they're at. And the reason for that is that the Puppet console will display an alphabetical list of the objects, of the node objects, if you look at a list. And so it's really handy to kind of get a feel for what that node group is. And so it'll show you, so like given the base, Apache, and blogs, you can clearly see where they're coming from. Just kind of a bonus. So having seen a bunch of PowerPoint pictures, let's actually look at these. I'll give you an example. So these are all screenshots from the enterprise console. And so here's our base group, which isn't our real base group, because we have a little more than this. But here's a pretend base group where the only thing I care about is SSH. And so the pieces of this are, if you guys are familiar with enterprise, you've seen this before. But the top are the variables, right? And these are the top level variables that you're setting. At the bottom left are the groups that this object is a member of. And as you can see, this is a member of no group because it's the top. And the other side is classes, and it shows you what classes, not only that this group is applying, but that is being applied, that it is inheriting. Again, this is, you're starting from the base set, so it's just SSH. And then at the bottom, which we'll talk about more in a little bit, are the derived groups. And these are the groups that are children, are nested within this Matryoshka doll. So just to go through this quickly, we're applying the SSH class on the right, and then we're setting the SSH port to 22. So pretty simple. But so pretend, and this actually works. I did this when I made the slide, but I'm too chicken to do a live demo. So pretend I clicked on the profile underscore Apache at the bottom left. Click. All right, so now we're in the profile. So the profile group, which is named profile underscore Apache, per our naming scheme, I helpfully marked out the new stuff. And so you can see that in this case, well, this is Apache, right? So we're just going to install Apache, right? This is very simple, but this could be as complex as you want. And this could be custom code, right? This actually could be a profile class. if you wanted to more accurately represent the way you do it in open source. And then I'm setting a variable called HTTP port, right? I'll just set it to 80, right? Just for the sake of argument, although I don't think you really do that. But you can see that even though I'm adding new stuff, that it is still inheriting from base, and it shows you what it's inheriting. And this, it's readable enough. You have to kind of look at it, is that you see that there's a key value and source. And it will always tell you where that configuration is coming from, but you got to kind of squint at it and figure it out. But in this case, it shows you SSH port it has the key of SSH port, the value of 22, and then the source is base, which is clickable. And so you can see how all this stuff is getting combined. Now in this case, it actually does have a group set up. Since it is a member, it is nested within base, and so the base is the bigger doll that it's contained with. And it does have a role as a derived group within it. So let's click on that role group. So it's role wiki. Click. This is, I guess that's OK. It's a little off the screen on mine. So in this case, I've added two different things. This is, now again, this is, so we've configured the base SSH. We've configured Apache. So we're good for a generic Apache server. But in this case, I want a wiki server. And for whatever reason, I've decided a wiki server should be port 8080. So I simply set a variable to that at the top left. And then it should pull from var www wiki. And so I set that as the HTTP source. And that's the only configurations that I make directly on this group. Everything else gets pulled from both the base and the profile. So at the role, just as in the standard open source kind of role profile model, the only thing I'm setting is what's specific to that role. But everything else is being inherited, so you don't have to actually change any of that data. And if that does change, it will inherit all of that. So there's a real value in this kind of in this nesting model. And this one I had to chop up a little bit because this is the role wiki is the final group, right? We don't have any group that's more specific than this. So this is the group that you attach your node to, right? This is the I don't know, cattle master or whatever. You know, this is where you attach the cattle, right? And so in this case, at the bottom right, I've created a wiki01 PuppetConf.com, which is a fake node, and you'll see by the exclamation thing. And so pretend that I click on the node. And so this is the end result of all of that work. And in the Puppet Enterprise console, if you guys are familiar with the resultant set of policy kind of idea, this is basically it. This will show you what configuration will be applied to a node because of all these different groups that have been stacked together. And so this is it. And so we get a group that has all of the stuff, including the default mcollective things that you get just by default, just by kind of it existing. And it's a wiki server, right? You got everything you need. And then presumably your configurations have support for fax, and we'll do IP addresses and all that. But this is as far as an example, this is pretty much it. So let's dig into a little bit of the kind of conceptual pieces. So from the Puppet console is broken up into basically 4 different primitives. You have classes, which are just standard Puppet classes like SSH. You have variables, which we make very heavy use of. If you set a variable in the console, it's a top-level variable. And so we actually have a naming standard where we say name of the class underscore name of the variable. That's how we do it, which is a little bit old school. And then we set groups, right? So in this case, right, the groups at play are base, profile Apache, and role wiki. And I think that's actually, if you like this scheme, this is probably, it's not a bad idea to kind of limit yourself to these kind of 3 groups in terms of nesting, which I think we're going to try to converge on. And then you have the node, right? And then the node is the node. It's the cow. So when you group the nodes like this, when you combine them like this, the classes and variables combine in slightly different ways. Classes are immutable. which is a word I've heard a lot this week. And by that, I mean that once they're set, they can't be unset. They are permanently set. And that's actually, we use that as something of a feature. Because the nice thing about this is that if you, let's say if you assign SSH to your base class, you don't want anybody to be able to unassign SSH. You want SSH to be configured on all of your nodes. And that is exactly what happens. What I show here is that if the base assigns SSH, the profile Apache can add Apache, and then the wiki role will inherit both of those and assign it to the node, but you can never take away SSH. So it's a way of being able to successfully kind of control your configurations by the way that you code these variables, and because it will be that class will be assigned downstream, which can be good or bad. So you got to be careful about what you assign at a high level. Now variables are a little bit different in that the child wins, right? Whatever variable is set closest to your node will be the one that wins out. And so in this pretty simple example, the base in this case doesn't set anything. And the profile, let's say in the profile Apache, sets an HTTP port of 80, right? Standard web port. And the wiki server decides to be strange on the right-hand side and set a HTTP port of 8080. And so its node inherits that variable. But the blog server decides to be standard. It doesn't set anything. And so it fully inherits through the profile and through the role that 80 port. And so that's a good way of kind of showing that you can set any configuration you want using that variable and then only override it as needed. And so you only have to set that once unless it needs to be different. Okay, so here is everything all put together. So here's an annotated version of Wikia 1. And so you see where the overrides are happening, and it shows you the key, the value, and where the source is. And so in this case, the source is coming from the role. So it's kind of self-documenting in that sense. The bottom left shows you the group memberships and their sources, so you see where the groups are coming from. And at the bottom right, you see the classes. And so that by looking at the node, you can, by kind of walking back and looking at the sources, tell where all of these different pieces are coming from. OK, that's enough of the ENC. So now we're going to switch over to the expert track. Now, in this case, we're going to talk about Hiera. Now, the interesting thing about Hiera is hierarchical, right? So in this case, it's basically directories. Now, what's interesting is that you can use Puppet console variables to point to different layers of your hierarchy and build hierarchy based on variables, which is pretty handy, actually. And so as kind of a refresher course, Hiera is for basically complex variables. It's for arrays, it's for hashes, but the key thing is to think of Hiera as back-end data mapping, right? Every Hiera is a key value in usually a YAML file somewhere on disk. And so we basically do the same thing with Hiera that we do with our nested console groups, and they map one-to-one. Is that the base maps to, if you look at this path is basically starting at wherever Hiera is based on your server at root, right? Root common YAML. And then the profile is based on the profile variable, right? So in the profile Apache group, you set profile equal to Apache, and you got yourself an Apache subdirectory. And so it can have its own common.yaml, separate from every other profile. And similarly for role, and role actually is nested underneath role wiki because these are all of this really kind of in the same way as the ENC. All of this combines at the node level, and so the node itself has a search path, which I'll show you. That's Apache wiki, Apache, and then base. Now, where this comes in handy is that on the one side you can delegate responsibilities using source control and code and data federation, which I'll show you later, to give people their own common YAMLs, to give people their own directories, so that you don't have people stomping over each other's YAML, which is a good thing. And so just to show you another picture of this, basically, if you look at an abstract version of this, the base, again, has no variable. The profile has a profile variable. And then the role is profile /role. And here's the actual YAML that in case you guys wanted to do this. And I've highlighted the bottom. That's setting the, if you guys are familiar with the Hiera.yaml, it's the data directory is given, and that's where all this stuff is rooted, basically. And then this sets up the hierarchy. And this is a very simple hierarchy, and we actually, in reality, have a lot more than this. But this starts at role, then it falls back to profile, and then it falls back to common. So this is basically a priority lookup. And so it'll look for, if you give it a key and you tell it to look it up in Hiera, it'll look in each of these in that order. And so I'll, to put all this stuff together, this is kind of how that maps out. Is that because remember how variables combine through the different layers, right? So in this case, the Apache profile is setting profile to Apache. The wiki role is setting role to wiki. And so the wiki01 node is actually getting both of those, right? So it has both a profile equals Apache and a role equals wiki. And so on the right hand, that basically works out to a search order of Apache wiki common, Apache common, and then common YAML. And so if you put a key in any of those, it will pick that up if you have the code. Or if you're using advanced Hiera, which I recommend these if you need them, you can use let's say if you had to build a hierarchy from multiple layers, like a firewall rule or sudoers or something, you could put a little piece of that at each of those layers, and then use a function like Hiera_hash or Hiera array to combine and to pull keys from multiple levels, which is very handy. I highly recommend it. It's fantastic for any of those +1 issues where you don't have to rewrite an entire YAML file. So the last thing I'll talk about is code and data separation. And this is, a lot of the Hiera pieces are intended to work with this. Because if you recall that the Hiera we're very specifically calling out different locations on disk to put YAML files. And this is where that pays off. Is that what we do is that we have a lot of, and right now they're Subversion, basically monolithic repos. But we have a lot of different repos for each of these groups, essentially. You have a base group for all of the base code and the base Hiera. You have an Apache repo, and you got a wiki repo. And a caveat here, this isn't really how we do it, but it's kind of a model of how we do it. And so all of that gets funneled into the Puppet server. And so what that gives us is that each of those groups has their own safe place to put their configurations. That we can separately ACL, they can separately make their changes, and it gives you a very kind of clean separation of duties. And the way that we do this basically on disk is we use VCS repo right now. VCS repo runs locally on the Puppet master, and then every 30 minutes it updates code, and this is the code aspect. It updates its code from the base repo, the Apache repo, and the wiki repo. And the way that we do this, which is really not very pretty, and I'll show you a better way in a minute, but we basically have in the PuppetConf a module path set to each that gives each of those a subdirectory, right? So there's an opt Puppet modules, base, Apache, wiki. And then when Puppet looks for code, it looks in that, and that's where it finds it. It's not pretty, but it works, and that's actually what we're doing right now. And so again, this is the value of this is that if we as a central group need to write an SSH module, we can put that in our base repo. If the Apache group needs to put something in theirs, they have their own repo, and they basically can manage their code at the repo level, and then we can simply pull it, right? So this is a pull scheme. And we're actually working on a push scheme, which is much, much cooler. And data federation works almost exactly the same way. I mean, literally, I took the slide and just changed the names. But you can see here how useful it is to be able to separate these, right? Because even if I had because this is actually a real issue, because a lot of times when Hiera does a lookup, you can do Hiera lookups based on based on facts, right? FQDN, IP address, different facts. but a lot of times it's going to fall through to the common.yaml. And so there are some things that are just very basic. And it was really handy being able to kind of on the fly construct hierarchies. And then being able to tie that to nested node groups was a real win. And this has been, in some ways, the best use of this that I found in terms of the nested node groups, along with not having to repeat the stuff at the node group level. And so it basically works the same way. You have Hiera in Base, Hiera in Apache, and Hiera in Wiki. And then it works exactly the same way. You have separate ACLs. So if an Apache developer makes a change to their YAML, they're basically just going to affect their stuff. Hopefully. That's the theory anyway. And so that's pretty much how things are right now. But we do have some, but there are some issues that we run into. One is that, like I said, all this is set up on the Puppet Master to run every 30 minutes. If you're developing code, 30 minutes is an awfully long time to wait to see your stuff. And so we've actually had folks set up kind of standalone test VMs to be able to develop their stuff. There was the possibility of running the Puppet Master manually, but frankly, VCS repo is a bit on the slow side with as many things as we're updating. And it also uses SVN as a back end. And it's basically doing an SVN update. And of course, we run into issues with if it wasn't a clean SVN update, then we get those greater than, less than signs, which Puppet does not like at all. So that was a problem. So there was a feedback delay that was problematic. We also didn't have automated testing. We didn't have CI set up. We didn't have continuous development, that kind of thing. And the requirement to ACL monolithic repos was a real barrier to entry. That we would have people who would want to make changes to core modules, and that would basically have to email us changes and say they could see it, but they couldn't update it because it was a bit difficult to give them access just on a per directory basis. So what we're going to do is that we're moving to a more of a Git workflow, and this is very much based on Gary Larizza's work. Just if you Google R10K Puppet, there's a lot of great stuff out there. I highly recommend it, and I'll talk about R10K in a second. Yeah. And so what we'll do is that we'll break up these. So like instead of having all of our core modules in a single SVN repo, we'll break it out into one Git repo per module, right? And the cool thing is, and we're actually using, we have a proof of concept on this right now. They're using Atlassian Git Essentials, and we're using Stash. And Stash actually has the ability to do per branch permissions. And so what we're going to do, what we have done actually, is that we lock down the head or the production branch, so that's our production branch, right? But then anybody else can come along, and they can branch our stuff, and they can make changes. And then those changes are actually, which I'll talk about in the next slide. I'm getting ahead of myself. But those changes will actually be automatically checked in Bamboo against our standard tests, which is very cool. But just breaking the stuff up into smaller pieces is a win all by itself. Oh, and Git is much faster to update. So the other part of that whole Git workflow is R10K. So remember I said we're doing pull deployments, right? So the Puppet Master's going out and doing SVN updates. So what we're going to do, we're going to change it to a push-based, so that every time you make a change on your test non-development repository, that will trigger a Bamboo run, which will test your changes, and if they're good, and we're using Puppet Lint, RSpec, all the standard testing tools. And if it's good, it pushes it to the server in a test environment, which is pretty cool. Which gets to the second point of the Puppet environments defined by code using R10K and Puppet file, which I highly, highly recommend, and automated testing and deployments. And all that's rendered in that pretty PowerPoint picture. So I'll start wrapping up but I still got a green light, so I'm good to talk for a few more minutes. So the takeaways is, this is, like I said, this is basically our business case for Puppet Enterprise. This is why we're using it, are these kind of tools that enable these kind of our UT Puppet Canon. But I think the important takeaways are that fact that I think it's important that Puppet as a whole, to kind of go back to that community, that it be inclusive, that it be, that you allow people on the novice side of that kind of spectrum to use Puppet in a real way. And the way that we do it is we say, if you have a node, you can plug it in, and you'll get 90% of what you need. And then allow them to get in using the Puppet community, using module documentation, all that, to get in, to kind of work their way up the ladder, so that we're all using that common tool chain, that DevOps approach. And as part of that, but it be secure by default, right? That you get all of the security stuff, just no matter where you plug in. And then it be highly federated. And I think that code and data federation, I think, is key, because you don't want all these people necessarily SSHing directly into your server. Nurture your Puppet community. I think that's really important. And nest your configs. I think that's pretty cool. And just, again, a quick plug. This is much easier to do in Puppet 3.4. If you look at the classifier demo, you can create a node, and then you can set its parent. And that you could basically replicate what we did by creating multiple nodes and setting the parent to that node that's the parent, and it's very cool, and the ACLs are amazing. That's pretty much it. So slide deck available from UT Puppet Labs. If you'd like a better picture of our architecture, I actually sanitized and sent it to, and put it on our public wiki. It has all our kind of nitty-gritty details, and it's much closer to how we actually do it. And I'd like to a shout out to my son for making Puppet Man. So I'm ready for questions if anybody has any. Yes, sir. Oh. Thank you, ma'am.
So this is excellent. Getting lots of different groups to manage their own modules. It's not just like the server group or the Unix group or something like that. How do you deal with the potential security issue that Puppet runs as root and people are writing these Puppet modules? How do you trust their code?
How do I trust their code? Well, code review, mostly. I mean, you have to, the people that we have in our group are sysadmins for the most part. And so they're mostly changing their own stuff. But yeah, it's, I think you have to trust the people committing to your things, But it's a good question. I guess trust, that sense of community. Anything else? Yes, sir.
So when you were showing adding nodes to the profile, to the roles,
yeah.
is that a manual task, or is there a way that you can automate, like when you're spinning up a new host?
That's a great question. Thank you. So I don't have to repeat the question if you had the mic, right? So right now it's manual for us, but there's two different ways that we're looking to solve that problem. One of which is we're going to be doing a kind of a CMDB. So trusted facts or setting facts of something. You always get back to facts at some kind. Now the other cool thing is and another plug for the 3.4, the 3.4 node classifier actually has the ability to automatically create, the groups are dynamic based on facts. And one of those, their classic example is a regex of the host name, if that's useful. So you could say everything that's www or everything that's wiki is a wiki server. And that would be a way of automating that, or just any fact that's useful to you. But that would be a way of doing that. It's probably the way that we're going to do it, honestly. Oh, sorry, got one in the back first.
Hi, maybe I didn't get it, but you have the node classifier from Puppet Enterprise and then Hiera. So if you want a particular value for a machine, you can set it in the node classifier and that would override Hiera or not?
I'm sorry, could you say it again?
Like imagine you have your group of wikis, but in one of the two machines, you happen to want a different value for the HTTP part. So you don't want to change the Hiera values, you want to change it through the Puppet Enterprise console, right?
Yeah, yeah,
And
that's
you would
right.
do it, that would override whatever Hiera says.
Yes, that's true. Part of that is to allow people who aren't necessarily editing Hiera to be able to change the value, so that you can have pretty much everything exposed via the console.
Okay, and can you see the values from Hiera through the console?
Oh no, I'm sorry, I didn't hear you. No, you can't.
Okay. All right, thanks.
Oh, and he had a question up front, unless there's anybody else in the back. Y'all need multiple mics.
How often do you have to refactor your base class when you discover that something is not as broad as you originally thought? That's a hard question to answer, honestly. We're still in the early stages, so we're pretty much doing that all the time. But yeah, I think that we'll probably stabilize at some point where we don't have to do that. But you're always going to have the, oh, Rel 7's coming, or, some X factor will come along. But it's probably a fairly consistent, if maybe slow trickle problem.
Could you talk about just a little bit more about how you do the Apache YAML and Hiera?
Sure. So like this one?
Yes.
Okay. So we've constructed kind of a Hiera directory based upon the node groups, right? Upon that kind of role, profile, common scheme. And I actually didn't list this in the order that it would be applied in. So basically, like if you set a hierarchy, somewhere in there, it would try to pull it from Apache Wiki, from the common YAML, right, the standard thing. Then it would try to pull it from Apache common, right, and then it would look in common YAML to pick that key out.
Got it. Thanks.
Sure. So are we done, or? Okay.
Thank you so much, Chris.
Thank you.